Okay, so we are going to go through this TDD Kata that I put together. I call it the alarms kata. And the background information is you're tasked with writing this code for a process monitoring application, and it's measuring a pressure in a tank. And if the pressure deviates too far from the set point, bad things happen. So if the pressure deviates by more than 5%, then a warning should sound. And if it deviates by more than 10%, then we should sound an alarm. So there's two parts. We're just going to do part one. So part one is use TDD to create a VI to calculate the alarm status. And we're going to use a fixed set point when we do this. We're going to set the set point at 100. So then the math is really easy. And our inputs, we have the set point. And for this case, we're going to assume it's always greater than 0. And then we've got the actual value, which is whatever we read in from the sensor. And our output's just going to be a string. And if the value's in the OK range, we're going to output OK. If it's in the warning range, we'll output warning. If it's in the alarm range, we're going to output alarm. And so on the right, I have a to-do list listing some of the things I want to make sure we test, some different conditions. So the first condition is if the pressure's in the normal range, right, it should output OK. And I've got 3 different points in there, right? So if it's equal to the set point or if it's plus or minus 4%, that should cover the entire range. And then the warning zone, we've got the plus and minus warning zone. So we've got plus 6 to plus 9% and minus 6 to minus 9%. And then when the pressure's in the alarm range, that would be plus or minus greater than 11%. And so I just randomly picked some numbers there that we're going to use for that. Okay, so we're going to minimize the description there. And I've got LabVIEW open already. And I've created a blank project called a Kata. And I've created a test class, right? So the whole tester and development thing is red, green, refactor, right? So the first step under red is to create a new test that will fail. So I'm going to create a new test from my template. And I'm going to say this, save as test underscore when the input is equal to the set point. So we'll call it equal. And OK is the output that we're looking for. Okay, so now we've got this test. And in here I'm going to, there's nothing for me to drop, but, right, I want the result to be okay. And I want the inputs to be, I'm going to make the set point 100, so it just makes the math really easy. Or add a label to that. And here we've got our actual, which in this case will also still equal 100. Okay, so now we've got this, right? It won't compile, that counts as our red. Now we're going to go to our green case. Right, which is do what we need to do to make it pass. All right, so I'm going to save that. And now I'm going to add a VI. And I've actually already created one with the inputs and outputs just to save a little bit of time. So if I go here and I add calc alarm stats, you can see that I have a set point and actual in, and alarm status out. And the block diagram is empty. So I'm going to drag this in here. I'm going to wire these up. Set point actual, and here's my output. I'm wiring that in. Alright, so this is my first test, and I want to verify that it fails, so I'm going to go to my LabVIEW project, click save all. I'm going to run tests. Right, and this should still fail, so definitely still just finished the red phase, right, moving into the green phase. I'm going to write my other 2 tests that I wanted here to plus or minus 4% to at the same time. Perfect. Now, right, we're moving towards the green. So what do I have to write in order to make these pass? highlighted. Let's just make a constant. And we'll call that OK. So this is the simplest and easiest way to make this pass. Now I agree, you're probably saying that doesn't seem quite right. That's okay. Our other test cases are going to cause us to change that. And if you run into that with TDD and you're like, I did something like this that doesn't quite feel right, and you run out of test cases, that probably means you're missing some test cases. All right, so now we are going to reload this. Actually, let's save this. We reloaded that, and let's run them again. They should all pass now. Okay. So great, but we're not done yet, right? There is something to refactor here. Let's take a look at our tests, right? All three of our tests have this check the string to see if it's okay. So we're going to turn this into a sub-VI. So create sub-VI. As complete. So before I edit my production code, I'm going to create some tests. So here we go. So we need to calculate 5% of the set point. And now we need to compare the difference. Right, but not just the difference, but the absolute value. Now we'll go back here and rerun our tests. All right, so first, now we're going to go back and refactor. Right, not a lot to refactor here. Our test, we're going to refactor this just like we refactored the other one. Alright, so we're going to make sure that all of our tests pass again, and they do, so that is good. So now we're on to our next step. So let's go mark all these as done. All right, so we did red-green refactor for the first step. We did red-green refactor for the warning zone, and now we're going to do it for the alarm zone. So first step is red. So we're going to write a test that fails. The red step, we got both these tests failing, so we need to implement the logic to detect that. So, I'm going to copy this. Now if I just reload these, and I need to reload them because I didn't really change them, and we run it again, it should pass. Perfect. So now we finished the green part. Now we're going to go back and refactor. Just like we refactor all the other tests, let's refactor these two tests. And the reason we're doing this, again, is that if for some reason the alarm text changes, we only have to change it one spot in our tests. So it makes our tests more maintainable. Let's see if we can refactor this at all. So we've got some duplicated logic in this right here. So let's see if we can create a sub VI. But now this is nice and easy and readable. We look at the set point of the actual, it says over deviation of 10%. Is it over deviation of 5%? So first we check the 5%, decide if it's okay or warning. Here we decide if it's over 10, we get an alarm. And there's our output. And we've got a set of tests to test it.